Welcome back. Today, I want to talk about, and that's why the format is slightly different, about hearing, where I'm not going to present anything. I just wanted to show you, number one, how human hearing works briefly. And then I want to go through a couple of key measurements that vibrometers have been involved with over the years, over the decades, and how it has been an instrumental part, vibrometry, in hearing research. So I wanted to explain how the hearing works, and I was gonna um, do something that's not a good idea, which is kind of show my ear. It's gonna freak some of you out. So instead, I have an ear model. So that's the model of a human ear. Maybe better seen this way. So, yep, our ear is pretty similar. It's smaller and not with a cross section. Um, but yeah, I just wanted to kind of show this to you guys so you can see the outer ear. And then there's the ear canal. This is where the sound gets in. It excites first the tympanic membrane or the or the eardrum. The eardrum is connected to three tiny bones which form the part of the middle ear. These three tiny bones are the malleus, which is first connected to the eardrum. The malleus is connected to the incus, and the incus is connected to the stapes, which is down here. So the three bones, that's also called the ossicles, middle ear ossicles, that form the middle ear. And then the middle ear is connected to the inner ear. The inner ear is then connected using a nerve to the brain. So that's how the mechanical motion gets transmitted to the brain by conversion from mechanical energy to electrical energy, and then that's how we perceive hearing. Um, it's a fascinating device. It still amazes me after all these years how well it works, how it's just at the end of the day, it's just a mechanical system, but it's just a fascinating mechanical system. I'm going to pull out a couple of these components so we can talk about it more. Yeah, that's the beauty of having a model instead of our ears. Even though there's a lot of research on these bones on various animals like guinea pigs, chinchillas, rats, and of course human temporal bones. So let's take these again. So you see the eardrum. The eardrum is connected to let's see, this one is right here. So the eardrum is connected to the malleus. The malleus is connected to the incus to the stapes, and then the stapes to the inner ear. One of the components you may have heard of is called a cochlea, which is this guy here. This is the cochlea, which has the hair cells. So what do we do? What does vibrometer? How does it come into picture? So one of the measurements we make is on the eardrum itself, especially at the umbo. Umbo is the point where the eardrum where the malleus is connected to the eardrum. So that's one of the important measurements. The other important measurement we do is also on these the incus and the other bone, the stapes as well. And that's when someone's trying to understand how good an implant is. So there are some implants or prosthetic components. So sometimes there's a damage in what's called the ossicular chain, and they replace one of the components, one of the bones, and then so you need to study how is the bone still transmitting mechanical motion from the eardrum to the stapes footplate. One of the measurements you will see that is very common is called a middle ear transfer function, METF, which is the transfer function between the measurement at the umbo to the stapes footplate. The footplate is the component of the stapes that connects it to the inner ear through a window where it's kind of placed called the oval window. So that transfer function is a good indicator of the efficacy or the efficiency of the transmitted energy, which could also be an indicator of how good the hearing is. Of course, the ultimate test of hearing is how well can we hear it. How good is the patient? What does the patient feel? Cochlear pressure is another methodology used to uh, gauge the efficacy of hearing or of an implant. There are predominantly two types of implants. There's a middle ear implant, and then there's a cochlear implant, which is in the inner ear. Uh, Polytech vibrometers are used in measurements to further the understanding of fundamental hearing. The measurements on the tympanic membrane, the stapes footplate, the ossicles inside the inner ear, on the basilar membrane, the hair cells. There's also some emerging research in understanding the effect of blast waves on hearing, and so we have been doing some of those measurements as well. Um, it's just a fascinating research area, and if you are remotely interested, it's definitely check it out. It'll give you an added appreciation for what a wonderful device our ear is. Thank you so much, and I hope you feel some of the passion that I feel for this application. Bye bye.